All right, here's our video today. What if the sun, snap my fingers, what if it just disappeared just like that? Which we know it's not going to disappear. The sun won't disappear. It won't even blow up. It won't become supernova because it doesn't have enough mass. It's only a little yellow star, just perfect for us. So it won't blow up in the future, like Betelgeuse may be in the future or other supernovas, but it will become a red giant. In the future, it will stop fusing hydrogen into helium. It will expand 5 billion years from now or so, but eventually its fate would be to become a white dwarf. So it's not going to disappear. But if it did, for some reason it just disappeared, maybe Q from Star Trek, if you know the Star Trek universe, or the Beyonder from the Marvel universe, somehow, or Thanos, maybe they just snapped their fingers and it just disappeared, what would happen? Well, first of all, we wouldn't notice for 8 minutes. And the reason is because the sun is 93 million miles away. So the light from the sun, it takes 8 minutes or so to get to us. So if it disappeared, we still have that 8 minute of the last light coming to us. So in 8 minutes, then we would know something is wrong. So if you look at the picture on the right, there's our Earth bathed in the yellow sun, the yellow dwarf. But on the left, it's a little misleading because, yes, eventually the Earth will become a snowball. But we wouldn't see it from space like this. If so, by chance we were in a satellite or we were in some spacecraft, we wouldn't notice the Earth this light because, of course, all the sunlight is bathing on it. So, what we would see, let's get a picture of that, we would see this, or even darker. So, the Earth will become a rogue planet. So, let's get our pen. Let's just put some numbers in here. Use red. Red should fit perfectly. So, again, the sun to Earth, sun to Earth, we're talking 93, on average, 93 million miles away. So light takes 8 minutes or so to get to Earth. So if here's the sun, let's say, for example, blah, blah, blah. It's not a red dwarf, but we're using red. So here's the sunlight, and we're saying, put a little arrow, 8 minutes. Now, the Earth is moving around the sun. It's orbiting the sun at a speed of 67,000 miles per hour. So when the sun disappeared, not only will the light stop, but gravity would stop. Remember, we're being pulled into the sun, and it's the momentum, it's that speed that we have that's giving us that momentum so we don't fall in. But the minute the sun disappeared, we would take this speed and we would just hang out. We would start heading in a linear motion wherever outside the solar system. We would become a rogue planet. No sun. In fact, all the planets and all the dwarf planets in our solar system, the comets, will become rogue. So eventually our planet would just become a frozen ice ball. We would see the stars though. We would see all the stars. We wouldn't see this sun here. So that's the only thing that we wouldn't see. Let's exit out. Wouldn't see this. Sun's gone. So it'll be darker than this picture, but we will see the stars. See more stars than we've probably ever seen before. And again, we're moving. We're going at a speed of 67,000 miles per hour. We don't know where we're heading. But let's say we were heading to Alpha Centauri or Proxima Centauri. Those are our closest stars to us, besides the sun. And it takes light 4 years to get there. So if we were heading to Alpha Centauri, that would take us about 43,000 years. So if we somehow managed to survive when we got to Alpha Centauri, which is a red dwarf, by the way, then we can bathe in new starlight, perhaps. Or we find another star out there and how many years in the future and become in a new solar system, become adopted. So here we are flying into space. The moon would still be attached to us. The moon will still orbit us. Of course, we wouldn't see the moon anymore because there's no light bouncing off it. So it wouldn't quite be like this. And we will be again moving as a rogue planet. And eventually, the first thing, of course, we should put a list down. Let's get our pen going. Let's just use this picture. Why not? Looks nice. So the first thing, of course, is the gravity. Gravity of the sun is gone. And now just the momentum of our speed will take us wherever, hopefully toward another star, but it wouldn't matter in our lifetime because it would take thousands of years. Again, the closest is 43,000 years to Alpha Centauri, Proxima Centauri. Total darkness. Now, as human beings, we will survive for a while, not the entire population. Remember, there's 8 billion people on this planet. Not all of us will survive, right? But we do have nuclear energy. We do have nuclear bombs. We do have fuel. So we could survive for a while. Actually, a few people will survive. There'll be a few chosen people somehow will survive. But that's a whole other video. So we got gravity of the sun gone, total darkness, and the temperatures will slowly drop. Remember, we have geothermal energy. So the temperature will slowly, not right away. So we'll say will drop. Of course, we know this is obvious. The temperature will drop. So in 4 months, remember, we still have an atmosphere. We are, covering, it's like a blanket keeping some of the heat in. But we'll say, actually, before 4 months, in 1 week, the average temperature on the planet will go, and we'll put it in Fahrenheit, 32 degrees Fahrenheit. That'll be the average temperature around the world in 1 week, which is not that bad. Of course, it'll be colder in other parts of the world. So 32 degrees Fahrenheit, that's 0 degrees Celsius. So instant winter wherever we are. So you can see right then, a lot of animals wouldn't survive. A lot of people couldn't deal with those temperatures. That's just in 1 week, and the temperature will continue to drop. And in 4 months now, the average, now we're talking about the average temperature on the planet will be minus 150. That's colder than Antarctica, degrees Fahrenheit. Very cold, not much will survive just from the temperature drop alone. That'll be number 3. Let's put number 4 over here. Number 4 is a major problem. There's no light, so no photosynthesis. That's a problem. No photosynthesis. See if we can fit it in there. So the plants can't make their own food. The plants die. And when the plants die, the plant eaters die. And when the plant eaters die, the meat eaters, those who eat the plant eaters, die. So that's a catastrophe all in itself. And of course, as humans, we can survive. Not all of us will. There'll be utter chaos. At negative 150 degrees Fahrenheit, it'll be very hard for people to go outside, use their cars, get fuel into their homes. So it'll be a complete mess. What else will happen? Oh, by the way, because of no photosynthesis, we can say, let's just, within 2 weeks, plants are dead. And there comes the chaos. Generally around the planet. Now, there are plants that are in the ocean. There's animals in the ocean, deep within the ocean, that will survive because they don't use photosynthesis. And remember, we have geothermal vents in the bottom of the ocean, so they'll be very cozy. They wouldn't even care that the sun disappeared. And so those microscopic animals and those animals deep into the ocean, deep by those geothermal vents, they can last for as long as the Earth is around, billions of years. By the way, some large trees, they store a lot of excess glucose, and so they may survive longer than 2 weeks, maybe a few months, maybe perhaps, because they could also hibernate. Within 2 months, let's put number 5. Within about 2 months, the oceans, because of the temperature drop, the oceans, and not talking about all the ocean, but the top of the oceans will freeze. So we will look like a snowball within 2 months. The oceans will freeze in 2 months. Not the complete ocean, That may never happen. Remember, because we have geothermal vents on the bottom of the ocean. And number 6, we'll put down within 1,000 years, no plants, no oxygen. The atmosphere could collapse within 1,000 years. See if we fit it in here. The atmosphere, our blanket, could collapse. So let's go back to our first picture. So the picture on the left, our snowball Earth, of course, without the light from the sun, heading 67,000 miles out into the sun. Within 1,000 years, what would be left? Maybe those creatures that lived near those geothermal vents on the bottom of the ocean, and a few humans who managed to go underground and using their technology to keep warm, their nuclear technology to keep warm. And one more thing about those oceans, again, it would take about 1,000 years for the oceans to not completely freeze, because remember those geothermal vents. So the oceans will get thicker and thicker with ice, and that will add to a blanket in a sense. So any fish that can survive deep within the ocean, and any creatures will survive, and if will survive. But any other animals just wouldn't be able to survive within 2 months. So within 2 months, all life on Earth would disappear except us and domestic animals and the fish in the sea. So that's what would happen if the sun disappeared. And by the way, the last thing we should say is about oxygen. It would take 1,000 years. Let's write that down. Where should we write it? Let's write it over here. It would take about 1,000 years for the atmosphere to collapse and to run out of oxygen. We're not going to fit it in. We'll put it over here. To run out of O2, which we breathe, oxygen, O2. About 1,000 years. So if we manage to stay on the surface with that a negative 150 and getting colder, if we manage to stay on the surface with all other animals, wild animals on the planet dead, a frozen ice ball, we could still breathe for a while, up to about 1,000 years. Then we would definitely need to find ways of surviving, and by then perhaps we would, or perhaps not. Anyway, that's our video today.